My name is Uwe. I'm part of the product management team for our middleware solution. And today, together with my colleague Suprith, we'll give you a short intro with our demonstrator.
Hello everyone, I'm Suprith and I'm the product owner for one of the teams at ETAS responsible for the demonstrator. Can you please tell us more about this middleware?
Yeah, sure. Maybe let's use the first picture of it. A middleware in principle is there an abstraction layer between underlying hardware and operating systems and applications on top. Reason for it is why this is needed. You may want to use the same application in different of your vehicle types. And those have different hardware underneath. And to have this abstraction, to make them exchangeable, that is why you need a middleware.
But there are already some standardized middleware out there like AUTOSAR Adaptive and AUTOSAR Classic. What is this middleware about?
Yeah, you're right. We do have, and the difference between the Classic and the Adaptive is the underlying hardware. Classic is microcontroller world. Adaptive is the processor world with a POSIX operating system on top. And that is also the hardware infrastructure we are addressing, because AUTOSAR Adaptive is not covering everything what we need in the development for autonomous driving functions. And here now these three topics I mentioned, what is not addressed by the AUTOSAR Adaptive standard. One is functional safety up to ASIL D, because when we talk about level 4, level 5, that has to be fulfilled, and that's at the moment not required by the standard. High-speed data transport. You have in a car like that 4 or 5 cameras, several radars, lidars. So you have a lot of data which you have to handle, even more than 10 gigabyte per second. That's also not yet defined in a standard how to do that without a lot of processing time involved. And last but not least, the deterministic behavior. So if you see some scene outside and you would like to double check that in the lab and want to reproduce it, that also needs to be exactly in the same way from the output perspective as it used to be on the road later on. And that is what is missing in the AUTOSAR standards. And that is what we are addressing in our middleware solution. And what we have here today with our demonstrator is focusing on the deterministic behavior part. And that is what we would like to show you. What we have in that setup here, we have a camera here on top of it. We will record a little scene like it would happen on the road. In this case, interactive, you can throw in some balls or dices. And after this recording is done, we let that run through 2 ARM controllers, where we have 2 different middleware solutions in it. One is our one and a non-deterministic one. And then you will later on see that there's a difference. And obviously, if you want to repeat your scene you have seen later on in the lab to find out why there was an error, it can't be that that is not the same behavior, because then you're not sure, was it now my middleware which was incorrect, or was it my software on top which had the failure? And that's the thing we want to show. And from the hardware setup here, what we said is we have 2 Raspberry Pis with an ARM infrastructure. Both have a Linux operating system on it. We have a deterministic middleware solution and a non-deterministic one. And we have OpenCV as object detection sitting on top of both of the middleware solutions. Now, let's go to the demo part. So what we will do now in the next step is we do a little recording. We will give this data to the 2 different systems and view the results here. So what we are doing now is we're doing a replay of the earlier recorded scene, and that runs in both Raspberries on the different middleware solutions with the object detection. Then, when this is done, now in the second step, we do a recompute. That would be, for example, in the laboratory. And then it is important that we don't see any difference between the previous recorded and the now recomputed variant. And here you see above the purple of the deterministic middleware is following that exactly. And in the non-deterministic middleware below, you see that that purple is not 100% following the previous run. So that means it's not deterministic. So and the explanation why this is so important will now come from Suprith.
So why does it even matter? If the car results and the lab results are not identical, then during the development phase, if I'm a function developer and if I'm developing an object identification algorithm, I test everything in my development environment. And when I try it on the real car, then I see a different behavior. And this, as a function developer, would not make me happy. Now, moving on into the next function development. Let's imagine we already have the first version of the object identification in the car running. And during a test drive, the driver reports an incident which was not ideal. Then we take the same measurement file and come back to the development scenarios. And then I want to recompute and reproduce the same situation again. And then I see this doesn't work. That would again not make me happy. And then the final phase, which is the simulation-based validation. This is the most expensive phase wherein you have to test your software before making it a release into the series vehicles. And this becomes much more expensive if you have to drive your car for thousands of millions of kilometers before a release. And this is where our simulation-based validation comes handy. Here you can use your previously recorded measure files and run your software, and this becomes the validation phase. This is where we can save a lot of money, and this would really make me happy.
On top of what Suprith just said regarding the middleware, which later on will be in the car, there is much more to come with it. It's an entire tool suite based on years of experience in the development. It contains things like the architecture, visualization tools, test tools, and so on to speed up your development process for your ADAS AD development.
Our middleware solution is already running in series projects.
Thanks for watching.
And we are looking forward to work with you.